Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now, quantum computing is receiving so much hype at the moment, but it's still a long way from widespread commercial applications. But another technology could become available much sooner, and that is quantum sensing. I hear what you're saying. Great Scott! What is it? Who uses it? How does it work? Well, these are just a few topics that we're going to explore in today's episode and hopefully demystify some of that technology and put it in a language that everybody can understand and learn what value it could offer businesses in multiple industries. But my understanding is quantum sensors can ultimately measure different physical properties, including things like temperature, magnetic field, and rotation, all with extreme sensitivity. And those sensitivities give the technology distinct advantages for applications, including communication, infrastructure monitoring, navigation, and radar. So today I've invited Henry White, lead technologist in quantum sensing at BAE Systems. So he's going to join me on the podcast to talk about how we can make sense of quantum sensing. See what I did there? We'll discuss the technology in more detail, as well as the current and potential real-world applications of quantum sensing around areas such as threat detection, especially in the military or at airports, for example. So buckle up and hold on tight, because no matter where you're listening to this podcast in the world, it's that moment where I'm going to beam your ears all the way to the UK so you can speak with Henry White, lead technologist in sensing at BAE Systems. And hopefully together we'll help everyone make sense of quantum sensing. So a massive warm welcome to the show. Can you tell the listeners a little about how you got here and ultimately share your origin story with everyone?
Oh, yes. Where do you start with those? Maybe very different to people these days. My primary school, we just had 4 people in my age year. So I was quite from a small rural school that went to, then went on to a comprehensive, and then went on to do a physics degree in Manchester. So that was great for me, getting to know a big city and seeing everything that could happen there. After that, I joined what was British Aerospace down in Bristol. And again, that's been quite a journey. I've been with the company since then, although we in 1990 changed to become BAE Systems.
Awesome. And as you said, that path led you to BAE. And we did speak with David Mariels on here a few years ago, but I think he's moved on now. But for anyone listening, I've got people listening all over the world. So if anyone listening wants to find out more information or just have a basic understanding of what you guys are doing, can you offer an overview and also what your role is there?
Yeah. Well, obviously, BAE Systems is a huge company. I mean, we're the largest defense and security company in Europe. I think we're about 89,000 people. So obviously, we do cover a huge range of things in the defense and security area. We're split up into different business units. I'm actually in the air business unit, but when I started with the company, I was in the central research part of the company, looking at various technologies that could be applied across the maritime, the air and the land and the security domain. So I think the best way to find out more about the company is to have a bit of a look at the website and follow any links on there. But really, we're about applying advanced technology in the security and defense arena to make, obviously, that's become more, the importance of that more aware to people this year, unfortunately. But there's a lot that goes on in the background as well.
Now, one of the main reasons I invited you on the podcast today was to talk about the topic of quantum computing, because it is still a while away especially from widespread commercial application. But there's another technology that could become available much sooner, and that's called quantum sensing. And I know this is your area of expertise. So can you introduce the listeners to exactly what quantum sensing is and the kind of problems that it could solve?
Yeah, okay. And again, it's another one of how deep do you start on this? And I think
Yeah, yeah.
it's perhaps thinking about what does that word quantum mean? And it comes to the fact that everything is built on smaller and smaller building blocks, but not infinitely small. So you can't keep dividing things and as much as you want. At one point, you come down to the quanta involved, both either in energy or in particles. I think a good example of that is maybe thinking about a beam splitter, or if you were looking out a window and you've got a reflection from the inside as well as seeing outside, you could imagine something where you're reflecting 50% of the light, but 50% of the light is going through. So a 50-50 beam splitter. But if you keep reducing the amount of light that's going through this, at one point you get to the fact that light is, as well as a wave, has a particle nature. So you then come down to the individual particles or the photons of the light going through. And when you come down to a single photon, that can't be reflected and transmitted at the same time. So you can't get 50% through. So it either will 100% go through your beam splitter or it'll 100% be reflected. And it's those really interesting effects when you get down to the quanta level in, as I say, either in energy or in matter, that you get some what would naturally seem very strange effects happening. And then we can actually use those for some very interesting applications as well. With things like that from the light side, when you're talking about does a photon go through or does it not go through, one of the immediate applications of that is in sort of random number generation, because you can't predict exactly what's going to happen, but you can record. And this can be used in a lot of cryptography and security applications that could be done in communication systems. So that's one of the more immediate applications of some of the quantum sensing and quantum effects.
And just to bring to life everything that you're talking about there, do you have any use cases or possibly examples of how it could be used in different areas? And I know you cover a wide scope here. So if I give you areas such as, let's say, communication, infrastructure monitoring, navigation, radar, etc., are there any use cases or examples that spring to mind that you are able to share with us today?
Yeah, I think to talk about those a bit more, I might have to talk about another of the quantum effects as well.
Sure.
But on that sort of photonic side with the light and the photons there, as I say, there is that application about putting security onto communication systems. But then there are effects where we detect the individual photons, and there's some very special detectors that can be used to do this. And also, people may have heard about entanglement, where you can have links between different photons. So when you detect one, you have some information about what's happening elsewhere. Now, these can be used for actually just really increasing the sensitivity of optical sensors, of cameras. But one particular application that they can be applied to is being able to see at a certain distance away from where you are. So rather than say you're looking in the sky and there's a cloud in the way, you can, in certain instances, look beyond that, because you're cutting out all the light that's coming from that cloud area and just looking at that distance behind. So you get a much clearer view of what you want to look at the range you're looking at. You've got to know where to look, but once you want to know where you want to look and the rest of it, it can give incredibly more detailed information than just a normal intensity camera would do. But I do think it's worth mentioning the cold atom systems as well, because they have a wide range of effects that are worth talking about. So here, again, we're talking about atoms of an individual element. So you might just have, tens of thousands of them, but they are very small in an area. And if you put these in a vacuum, say just a centimeter cube vacuum, you can actually shine laser light onto these atoms in the vacuum. And the lasers, if you tune them right, can be used to take energy out of the atoms. And what you're doing is you're actually slowing them down. So when they're moving towards you, you slow them down. When they're moving away from you, you don't do anything, but you've got another laser beam coming from the other direction to slow them down in that direction as well. And when you do this enough, the atoms effectively stop. They just become still in this vacuum. And I think an important thing to try and remember about temperature is the temperature of something is the movement of the atoms in it. So when you've got some atoms that aren't moving, they're very close to absolute zero. And then again, they behave in very standard and controlled ways. So one application is they will oscillate, and the oscillations of that will be very, very consistent and regular. And this can be used for getting much higher clock accuracies. So there's a range of quantum clocks and oscillators that have been developed that have by far the highest accuracy that anything's been produced. So, for example, they believe that if you'd had one of these clocks running, they would have lost about 4 seconds over the lifetime of the universe as a whole. So you can see over the times that we want to use them, they're incredibly accurate. So important applications for those are actually being able to know when you're measuring something and when you're doing it. And that comes back to combining sensor systems, which maybe I'll say a bit more about later as well. But the other thing about those is the oscillations of that can be done with very low variations, and this can be applied to radar systems as well. So that enables you to take out a lot of the fuzz and the noise that you'd see in these radar systems. So rather than a bit of blurred image of what you're looking at, it's a bit like, wiping off the muck from in front of your camera or cleaning a glass window. By increasing the accuracy of the oscillators you use in the systems, you really do get a lot more clarity on what you can see and where you can see it.
And you mentioned radar a few moments ago there. So if we dig a little bit deeper on that, how would it work in something like, let's say, threat detection in the military or at an airport, for example?
So threat detection in the military, the particular applications for those radar systems is really the range of what you can see. So it may be more from an aircraft radar system or a long-range warning radar system that it gives you a lot more information earlier on about what you're looking at. And from an aircraft point of view, increasing the sensitivity of your sensors on a platform means you might design the platform in a totally different way. So if you can see further and understand what you're looking at further, you might not want to go as close, you might not need to go as fast. So it then changes your design on engines and all these aspects of a platform as well. So it's really important to understand what can be done. And that's actually one of the challenges we've got as BAE Systems is there's this fantastic technology out there, but can we build it in and integrate it into something that will work in the harsh environments that we do? But on maybe an airport detection system, one of the aspects of those cold atom systems is that you can actually detect gravity, and you can detect the gravity that's caused by not just the Earth, but by all objects, and so from much smaller objects, or indeed cavities. So you could use it to be detecting, is there a cave underneath what you're looking at, or is there a concealed mass in an object that's being carried? So that's the sort of detection capability that might be applicable and applied at airports in the future.
And one of the things I always try and do on this Daily Tech podcast is demystify technology, put it in a language that everyone can understand so business leaders can understand the value that they get from that. And I think you've done a fantastic job of giving an overview today. But we will also have a few techies listening, wanting to learn more about what goes on under the hood, how it all works. So can you help them understand and help them make sense of what quantum sensing is? And feel free to geek out on this one for the techies listening.
Well, yeah, if we talk about those cold atom systems, so there you've got something like rubidium atoms in this small cell, vacuum cell. You're shining in light onto it, and one of the critical aspects of that is the wavelength of the light that you're shining on, because I talked about you want to affect it when it's coming towards you, but not when it's going away. And the only thing you've got there is the change with that is the Doppler effect. So that the wavelength change that you get when something's moving towards you or away from you. I mean, that's often referred to with the stars in the blue and red shift that the astronomers looked at. So, but this happens at the quantum level as well. So when you've been able to use these lasers to sort of freeze the atoms in place, you've then got the effect that the Heisenberg uncertainty principle, where you know the movement, the acceleration of something, you don't know exactly where it is. So these single atoms just spread out into clouds. And then you've got a number of these atoms all together and they form one cloud and they all work together. So then you're going almost in the opposite direction from the optical point of view. You're taking these atomic particles and then they're behaving like waves. So you can then use interferometer aspects of these where you can split the atom clouds, combine them together. And what you're doing in one arm of this can be used to measure something very sensitive. So that's where the same principles of these cold atom sensors can be used in a lot of different application areas. You can measure temperature, you can measure acceleration, you can measure corrosion, because you can measure the electrical changes in currents and magnetic fields. So some of these systems are being used to detect corrosion of metals, but the same similar principles are being used to detect brain waves. And so people can hopefully do medical applications of understanding brain damage and how people are responding to various treatments in a lot more friendlier manner to the patients.
And I'm curious, how does quantum sensing extract data at that atomic level that you described?
I suppose it's fair to say the data we're extracting is data from the environment. And so it is how that environment impinges on either the photons or the atoms that we're dealing with. So as I say, there'll be a number of effects that will affect on, say, the cold atoms. And what you want to do is isolate the parameter that you want to get data from. So almost any sensor can be turned into a thermometer, because temperature affects everything, and you want to isolate that out if you want to measure acceleration, if you want to measure how fast you are moving or where you are. You need to measure that acceleration quite accurately, and you want to rule out the gravity effect as well. So there are a number of these systems where you've got to actually measure a range of different parameters. And again, that can be done with lasers interrogating the atoms. What you're looking at is the energy shifts in the atoms, and these can be done by absorption through laser beams. So I don't know whether that was a long-winded way of saying it is the data in the environment that you're trying to measure by the effects that environment has on the energy levels and the quantum states of the quantum sensing systems.
Perfect answer. I think you covered everything there. And the question I've got to ask, and I appreciate you probably can't reveal too much, but who is using quantum sensing at the moment? Are there any names or industries that you can share?
Yeah, I mean, it's probably in terms of quantum sensing systems being used in anger, it's in its infancy. There's a number of quantum communication systems that are commercial products that are out there that people are using. But there's a number of, in the quantum sensing area, a number of companies looking at the development of systems and sort of ready to maybe deploy them and use them in anger in the near future. I mean, we're working with BP. They've done a trial recently of a quantum clock on the Prince of Wales aircraft carrier. We're also working with BT on both the sensing area. So again, if you can understand what's beneath the ground before you dig it up, that's always good for all of us before all the roads are dug up, to repair a cable that was perhaps in the wrong place. So those sort of applications are really real and trying to get matured in the near future. But one important aspect for ourselves and for other companies is the positioning. A lot of what we do and we rely on is GPS, so that using the satellite navigation systems, but they are vulnerable. They are vulnerable to both accidental and deliberate interference, and also in some environments they're not as accurate as we'd like them to be. So there are ways of using these quantum sensors, both timing and the position information, to know when and where you are much more accurately. And that can play a big role, we see in the future, in the navigation aspects. So both from the military side, but all on the civil side as well. And that's going to be particularly important when we go to more autonomous vehicles, both maritime and land as well.
And I suspect you're only just beginning to discover and learn all the different areas and how and where this technology might be able to be used in the future. But what specifically excites you about the future potential of this technology? Where do you go from here with it?
Yeah, I think that's one of the things is, I wish I knew the full answer to that. But one of the things I think is really exciting is that knowing when and where you are to much more accuracy, and that the power of that is in being able to combine different systems in different locations. So rather, say for example, I've got my sensor on a boat looking out, combining that with an aircraft sensor, combining that with something on the land as well. Being able to combine those accurately needs real precision on terms of when and where you are, and that's what some of the quantum technologies can do. And I think once we're able to do that, what we will be able to see about the environment and, being able to use that in terms of, search and rescue applications and things like that will just increase exponentially in the future. But the trick is, getting it to work on these platforms and not just in the lab systems.
Fantastic. Incredibly cool, the technology that we're talking about here and where it leads.
Literally very cool, actually.
Yeah, I'll see what you did there. But we started the podcast talking about your origin story, what put you on this path, how you got where you are. Now, as we come full circle, I'm now going to ask you, I think that none of us are able to achieve success without getting some kind of help along the way. So I'm going to ask you, is there a particular person who you're grateful towards who possibly helped you get where you are today? And just give them a bit of a thank you and a shout out. Who would that be?
Yeah, I don't think I'm going to name any names, but I think one thing I would like to say is that, and I think this comes to different people at different stages in their life and career, is the help you get from people to make you believe in yourself and that you've got something that you can say and is worth saying. So building that self-confidence. And I know there was one individual who particularly at one point in my career really did do that for me and made me realize that, I should stand up and talk a bit more about what can be done and build that self-confidence. And some people do get that from, very early age, and some people get that much later. But I do think that's very important for everybody and something we need to be mindful of in whatever we do, in making sure we bring that out of other people in the future as well.
Completely agree with you. Wise words indeed. And I'm sure we'll have a lot of people listening today that are hearing about quantum sensing for the first time. They're going to want to dig a little bit deeper, find out more information and the kind of work that you're doing with it as well. What's the best starting point for everything quantum sensing and what you're doing there?
Yeah. So obviously for BAE Systems, we've got our website, but obviously as such a big company, that can be quite corporate. So you can go through that and eventually you'll get fed through to the right people. Yeah. Myself, I'm on the LinkedIn social media, and in that we've got a group on which we call NAQS, NAQS, National Accelerator for Quantum Sensing, where we're a group of us in different companies are discussing developments to take these technologies forward. So that's a good way of doing it. Otherwise, coming through BAE Systems and getting through directly to myself is a good way, and we'll take things forward and be happy to follow up with any questions that people might have in the future.
Awesome. And I suspect that many people listening at the beginning of the podcast would have heard of quantum computing, but not quantum sensing. And I think excuse the pun, but you have helped everyone make sense of that topic today, and also for discussing the technology in more detail. But more than anything, for sitting down and sharing your story with me and the potential real-world applications of quantum sensing. It's incredibly enlightening. I myself am going to be digging a little bit deeper on this at the end of our conversation today, but just thank you for joining me and sharing that with me.
No, my pleasure. Thank you.
So before today's conversation, I'm curious, how much did you know about quantum sensing? And did today's conversation help you at all? And do you have any experience in this field? And would you like to join me here on the podcast? Because today you've heard from Henry, you've heard from myself, but the way this podcast works is by everybody sharing their opinions, insights and experiences. So if today's episode has left you with any additional questions, or you'd like to come on here and show a different side, simply email me, techblogwriter@outlook.com. My website is techblogwriter.co.uk. So give me a shout if you'd like to come and join me on the podcast. But today's instalment was all about quantum sensing. But where do we go from here? What tech can we demystify tomorrow? Well, it's time for me to spin the wheel, which will reveal tomorrow's topic. But I am going to keep you guessing and invite you to join me again tomorrow to explore another area of technology and how it's transforming our life, work, industry, world, or anything in between. But that's it for today, so a big thank you for listening as always, and until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.